Today, I'm going to walk you through a comprehensive line by line and endpoint by endpoint presentation of IntelliSupport, a production ready autonomous customer support intelligence platform built from the ground up for a project management SaaS company named Nexora. Before we look at the code, let's understand the problem we are solving. Customer support departments in SaaS environments are often overwhelmed with recurring inquiries about billing, integration, and configurations. To build a system that can accurately answer these questions without hallucinating, we implement the Retrieval-Augmented Generation RAG pattern. Unlike basic RAG tutorials, IntelliSupport is built entirely from scratch without using LangChain, LlamaIndex, or any other high level orchestrator. Writing the pipeline from first principles using raw SQL and direct API integration ensures complete control over chunk sizes, retrieval logic, prompts, and evaluation metrics. Let's walk through the architecture flow on the screen. Intent classification. Every incoming query is first satisfied into one of the seven predefined categories. This helps the system determine if context is needed or if the query can be handled directly. Then, semantic search. We convert the query into a 1536 dimensional vector embedding using OpenAI's text embedding tree small and run a similarity search against the database chunks restored in PostgreSQL using the pgvector extension and the cosine distance operators. Sparse keyword search in parallel, the query is passed to an in-memory BM25 index to catch exact key matches, error codes, and specific integration names. Hybrid blending and re-ranking, the dense and sparse retrieval scores are normalized, blended using an alpha parameter, and then re-ranked using a lightweight token-based Jaccard similarity scorer to pick the best reference paragraphs. Ground and response generation. We construct context-rich prompts citing the source chunk IDs, restricting the LLM's response strictly to retrieved information. Automated LLM as a judge evaluation. Finally, we run automated evaluation judges to score the responses, faithfulness for like checking for hallucinations and relevance, like for the retrieval quality, before updating the records in our database. Let's dive into the implementation, starting with the setup and migration. First, let's talk about containerization and environment setup. The project is fully containerized in the Docker compose.yml file. You can see two main services defined here, which is DB and API. DB, this runs the official pgvector pg16 image on port 5432, providing a PostgreSQL instance pre-configured with vector math capabilities. API. This builds a Python 3.11 environment using a custom Docker file. It exports port 8000 to serve our fast API web endpoints and relies on the database being fully healthy before starting. Uh, let's take a look at the environment configuration. If we open the env file, you'll notice the custom setting like mock OpenAI is equals to true because OpenAI API keys require a prepaid balanced to run, and the keys might easily hit rate limits of quota. When the mock OpenAI equals to true is set, the system bypasses external OpenAI API endpoints and uses local hashing to generate mock embeddings and responses. This allows us to run the database seeding, search queries, and tests locally for free without any internet connection. Let's look at the database schema. The database tables are defined in database migrations here. We created five core tables inside the IntelliSupport schema. Documents to hold document metadata and raw content. Chunks containing a vector, a column for vector embeddings linked to the document. Queries logging user questions and classified intents. Response tracking generated answers, cited chunk IDs, and faithfulness or relevance scores. And the last one is feedback, logging customer star rating 1 to 5 and reviews. Now let's run the seeding process in a command prompt. The command is when we run the script reads out 10 core product support documents, which contains realistic documentation about Nexora's onboarding, billing, integrations, and 2FA settings. Chunks them, generates 1536 dimensional embeddings, and saves them in the database. As you can see, 10 were chunked, embedding, and stored successfully. Now let's review the code starting with the ingestion pipeline. If we go for the ingestion, we define a document model using a pedantic. The document loader class handles the incoming dictionaries, validates the document ID, matches the pattern document using regular expression, and ensures that the document content is not empty. This save to DB method uses a raw SQL with on conflict document ID. Do update to perform an upsert pattern directly to PostgreSQL. Moving on to chunker.py. The document chunker splits the document content into semantic paragraphs based on sliding window word token approach. It respects the maximum chunk size and chunk overlap settings. Every chunk gets a deterministic ID format using a chunk doc and a chunk ID to maintain the order of the paragraph. Next, let's inspect the retrieval system. In the vector store.py, you can see the vector store class. The similarity search method formats the query embedding list into PostgreSQL vector string representation and runs a raw SQL query. It uses a pgvector cosine distance operator less than equals to greater than to rank the chunks. Converting the distances to a similarity score using the formula score which is 1 minus the distance. The BM25 retriever class loads all the database chunks into the memory on starting up and initializes the rank BM25 index. The search method tokenizes the query, retrieves the term frequency scores, and normalizes the scores to 0 and 1 scale by dividing them by maximum score in the set. To prevent fast API container startup crashes before database tables are created, I wrap the database query inside a try except block. In Retrieval-Index, now let's look at the core retrieval blender. The hybrid runs both vector and BM25 searches. The results are merged using an alpha weighting formula. Let's look at the classification and generation modules. In intent classifier.python, the intent classifier categorizes query intent. When offline mock mode is active, it uses the keyword, local keyword matching the determine the intent, like building technical issues, etc., with a confidence score. When online, it calls the OpenAI API using the structured JSON mode to get the same intent details. In prompt-builder.python, the prompt builder constructs the system and user messages. The system prompt establishes the assistant rule as the support bot and enforces strict anti hallucination rules. If the content is insufficient, the bot must reply exactly with I don't have the information about exactly with I don't have like in the build track prompt. We forgot the context chunks listing their document IDs and chunk IDs so the model can cite which chunk it is used. In response generator handles LLM generation. It also implements the mandatory generate with fallback logic. The response is shorter than 20 characters or contains I don't know. It automatically triggers a fallback prompt asking the customer a polite clarifying question. Evaluating generative AI is critical for enterprise pipelines. In the faithfulness.py, the faithfulness evaluator represents as LLM as a judge. It extracts all factual claims from the bot's response and checks if each claim is supported by the database chunks. The faithfulness score is the faithfulness score is a fraction of supported claims over the total claims. In relevance.python, the relevance evaluator scores search the relevance. It rates the each chunk from 0 to 2, where 2 is highly relevant and 0 is not relevant, returning a normalized 0 1 relevance matrix. The evaluate response method queries the database records, runs both evaluation, saves the resulting faithfulness and relevance scores directly in our response. The run benchmark method runs our entire RAG pipeline end to end for a list of standard test cases and outputs retrieval, hit rates, intent accuracies, and average judge valuation. Now that Now that we have seen the code, let's run a live end-to-end API test using a fast API Swagger interactive documentation in our localhost 8000. Let's start by testing the health check endpoint. When we execute it, it checks the database connectivity and counts the seeded chunks in the database. As you can see, the response like okay. Yeah, after running, you can see like the status is okay, DB connected is true, and chunks index is 10. Now let's execute the customer support query. We expand it. We can click the execute like after we click the execute, the backend classifies the intent integration with 90% confidence. After we click the execute, the backend classifies the intent, and we have got this intent classification with 90% confidence. Embeds the queries the hybrid retrieval to full stack documentation and generates a grounded response with chunk document like 004 and saves the records. Here is the responsive object return with an unique query ID and a responsive ID. Now let's copy the return responsive ID, which is like RSP something, and execute the evaluator. We expand the evaluate response ID, paste the ID and click execute. The pipeline evaluator retrieves the query response from the database and runs the faithfulness, relevance, and combined scores. Updates the database records with our score. As we can see, like it returns the faithfulness score, relevance score up here. Finally, let's test the feedback loop. We expand the feedback loop. Submit a 5-star response. Executing this inserts the feedback entry into the database. We can get the query summary with get feedback summary, which aggregates our rating loss. We can execute the test in a command prompt using Docker. These are the step-by-step installations and how to launch the service, running the API, running the suite, and the evaluation report here. Thank you so much for watching. IntelliSupport successfully demonstrate how to construct a complete high-performance RAG pipeline from first principles using a raw SQL, pgvector, database queries, and custom evaluation. Hope you like the video. Thank you so much.